Hey everybody. Let's talk about how to do a keyboard split on the Poly Beebo. So one MIDI channel, right? I want different ranges on this key bed to control different sounds, different sound sources, different voices in the patch. I thought it wasn't going to be that hard, but it was a bit of a learning experience for me, so I figured it'd be useful to maybe walk through this patch, put it on patch storage. I think once you get this concept, it's fairly useful in lots of different applications. You could do CV switchers and all kinds of different things with some basic math. And so I'm going to load a demo patch to go over the basic concept here. So what we have is a single voice synth. Here's the synth voice going through this VCA to the output. The envelope going through an attenuator to, since this thing runs pretty hot. And so that's your voice. And we have a gate going out the MIDI note through to the envelope. And so I'm going to turn off this min module here for now. And in this configuration, every time I press a note on the keyboard, I get a sound. So what I want to do is filter the gates going through to the envelope based off of the frequency of the note I'm pressing. And in order to do that, we need this min module to function as a logical AND operator. So I'm sending the frequency to the B side of this, the frequency CV, and I'm sending the gate CV to the A side. So the way that works is only when both of these go to 1 will I get a gate signal out. So A goes to 1 every time I hit a note, but the B signal will only go to 1 when the frequency CV is 1 volt or higher. So the simplest split you can do is just to send the frequency straight through on the B side, and what you get is this. So that C there in the middle is where the split is occurring. And that's because that C is where the voltage is at 1, I'm guessing, right? I can't, in the Beebo, this is one of my the highest thing on my wish list for this device is to be able to scope these wires, the inputs and outputs, to see what's going on. But right now, I'm guessing that that's 1 volt, and that's why this is working. Now, if I want to change the split point, what I do is some math on that frequency. So I'm actually sending frequency to this difference. And if I subtract the voltage from the frequency before I head to this min, then the voltage of the frequency is going to have to get a little higher in order to hit 1 volt and trigger this AND gate, the minimum to be 1 volt when the gate comes through, and that'll trigger the envelope. So what I do here is if let's say I want to make that three tones higher, that split, I just set this to 0.25, which is, there are 12 notes per octave, so 0.25 is 3 out of 12, 1/4 of 12. So 0.25, if I subtract that, my split should get 3 notes higher. And we can see that now the split is at that E flat, which is exactly what I want. If I set it to 0.5, the split is on that F sharp. And if I go 1 volt, if If I subtract 1 volt from the frequency voltage, then it's going to have to get a full octave higher, so my split will now be at that higher C. Very nice. But what if you want to go higher? Well, you're going to have to send a higher voltage to this difference B side. And in order to do that, right now, I think the best way to do that on the Beebo is to use this ratio CV module, which divides A by B. So right now, this is 0. This is outputting a 0. 0 divided by 1 is 0. But if I wanted to, let's say, output a 2, then I basically set this to 0.5. And 1 divided by 0.5 is 2. So this should be sending out 2 volts. And now my split should be 2 octaves higher. It's a little off. Can adjust that. Perfect. Or up. Anyways, you get the idea. It's not quite easy, but it's doable. And if I want to go even higher, I can go down to, let's say, 0.33. That is going to put me right about this octave right here. So now I'm limiting the gates in to just the top range of the keyboard. So that's how you make a split the keyboard into 2. And to do the reverse, it would be the reverse logic here. You would basically switch your difference operator, and I do that in this patch. So I'm not gonna. I don't want this video to be too long. I'm not gonna go into every detail here. Feel free to download the patch and check it out. See if you can figure out what's going on. But really quickly here, I'm actually doing the splits all in slightly different ways. So this top split is exactly what I just showed. It's just one difference operator. I don't need the ratio operator, the ratio module, because I'm just doing it 1 volt up. I don't need to go higher than 1 volt, so I don't need the ratio. So this top section is the top split. I am using this is another cool little trick you can do if you haven't tried it before. Pretty common trick. Take an LFO, set it to whatever you want. I have it set to a random. Feed it into a sample and hold. And the sample and hold is getting that same gate message as its trigger. So every time I press a note, it's taking a snapshot of what that random oscillator is at. That is mapped to the macro oscillator's synth engine. So what happens is every time I press a note, I get a different synth engine. That's a fun trick if you want some bleeps and bloops, which I usually do. And so, okay, yeah. So the middle one is a little bit trickier because you need to chain 2 of these min modules together. One to do the lower part of the range, the lower split, and one to do the upper split. So this middle area is where I'm doing the middle, the snare. And then the bottom is the bass. I am sending pitch to the bass as well. Also on the top, I'm sending pitch so that I can control the pitch of that bass note with that bottom split. The bottom split is a little different. What I noticed, I think what's happening here is this area of the key of the MIDI to CV is actually putting out a negative value. So what I did is I created a -1 voltage by subtracting 1 from 0. That gives you -1. And I feed the frequency into this multiply, this product, and I'm multiplying it by -1 so that the negative voltages at that bottom section of the keyboard are converted into positive voltages, and the positive voltages up here are converted into negative. So the bottom part of the keyboard getting more negative is going to go up to 1, and that's what allows those gate messages to go through down here. So that's another way to create a split. If you want the bottom half, just go ahead and multiply by -1, and you got it. So, you know, that's it. If you can figure out, I'm gonna cut this video off, but if you can figure out why this envelope doesn't seem to be closing all the way, let me know. I don't know if y'all can hear that, but I'm getting something that I don't want in there. I'm not sure if it's the envelope or if there's some kind of problem in my patch, but yeah, all right. Cheers, guys and gals, and all Beeboers and polyers and modularers, whether you are robot, human, or some other sort of ghostly apparition. Goodbye.